Good day everyone, we are group Deepsea, and for this video, me and my groupmate were sharing about the MV Golden Ray RoRo capsize at coast of Georgia.
Good day everyone, today we'll be talking about the MV Golden Ray incident. On September 8, 2019, the MV Golden Ray, a roll-on roll-off cargo vessel, was capsized near the Brunswick, Georgia shortly after departing port. So this ship was carrying over 4,100 vehicles, and the total cargo loss was estimated at $142 million US. So the investigation by National Transportation Safety Board reveals several major causes behind the capsizing. Firstly, there was a lack of proficiency and operational failure. The chief officer had entered the incorrect ballast tank data into the ship's stability system known as LODCOM. So he was not given the proper training and was also unfamiliar with the system. The second issue was the failure to maintain the watertight integrity, where the watertight and pilot doors were left open and there was no checklist or enforcement mechanism to ensure they were properly secured. This leads to the water flooded into the critical space and when the ship capsized. Thirdly, there were also flaws in the emergency escape room, particularly in the engine room. So this leads to the crew members were trapped inside and unable to evacuate when the flooding occurred. As a result, the rescue of 4 trapped crew members was delayed by over 40 hours. The ship also suffered extensive structural damage, highlighting significant gaps in both emergency preparedness and operational safety. In response, GE Marine Service had took several corrective actions, such as revise their safety management system, implement new procedures for stability verification, and also replace the old software with the new advanced system. And also the officers were retrained, and the final load plan verification become mandatory before any departure.
In the case of MV Golden Ray, and the capsizing even posed a serious risk both to human life and the surrounding marine environment, my part of the sharing will focus on how these two areas were protected during and after the incident. When the ship capsized, 24 crew members were on board, thanks to the quick response of the US Coast Guard and other rescue teams. All crew members were rescued alive, even though 4 of them were trapped inside the overturned vessel for more than 30 hours. Advanced tools like thermal imaging, sound detection, and precision drilling were used to locate and safely extract the trapped crew. This showed that the importance of well-prepared and trained emergency teams, clear communication, and international cooperation in the maritime rescue operation. The capsized ship was carrying over 4,200 vehicles and more than 300,000 gallons of oil and fuel, which made it a major environmental threat. If not properly handled, this could have led to the oil spill, battery acid leaks, and heavy metal pollution in the coastal waters. Fortunately, the response teams acted quickly to contain the pollution. Oil containment bombs were deployed around the vessel, and skimmers were used to remove the visible oil. When it became clear that the MV Golden Ray couldn't be righted or refloated safely, authorities chose a rare and complex solution to dismantle the entire ship on site. This required cutting the ship into 8 massive sections, used a heavy-duty chain suspended between 2 lifting vessels. Each section weighed hundreds of tons and had to be lifted out using a float crane. Before each cut, teams removed as much oil, fuel, and hazardous materials as possible to reduce the environmental risks. Even so, the operation carried serious long-term risks. Cutting open a ship filled with cars, batteries, fuel residue, and wiring meant that leaks and fires were a constant danger. In fact, a small oil spill, floating debris, and 2 fires occurring during the removal process. These were quickly contained using fire suppression system, barrier walls, and oil collection tubes. To protect the local environment over time, a 1-mile-long environmental protection barriers were installed around the wreck. It included turbidity curtains to reduce the sediment spread, and solvent materials to capture any oil or chemicals that escape. Continuous air and water quality monitoring was carried out throughout the entire operation, which lasted over 2 years. Additionally, wildlife response teams were on standby to protect the marine animals like sea turtles, dolphins, and fish that might be affected by the pollution or underwater noise. In summary, the operation focused not only on removing the wreck but doing so in a way that minimizing the long-term ecological damage, a model approach for future salvage effort involving high-risk vessels.
Good day everyone, today I will be discussing about the critical risk and lessons from the capsize of the MV Golden Ray cargo ship off the coast of Georgia. Starting with the environmental and financial risk, the capsizing caused immediate threats of fuel leakage and pollution, putting the local marine ecosystems at risk. Salvage efforts were complex and lengthy, involving disassembling the ship in section to prevent the further environmental harm. Financially, the impact were severe. The vessel was valued at $62.5 million and it carries about 4,100 vehicles worth roundly around 142 million, all lost as cargo. The salvage operation itself became one of the costliest in US maritime history, underscoring how an accident can trigger the extensive economic consequences beyond the internal losses. The next one is human life risk management. Moving on to human rights life, the root cause was a critical human error. The chief officer incorrectly entered bonus data into the stability calculation program. This error meant the ship was less stable than reported, and unfortunately, the operator has no system to verify this calculation. Worse, during the incident, 2 watertight doors were being left open. This caused the floating trap 4 crew members inside for about 40 hours. This highlighted the gap in emergency preparations and procedures, raising the importance for comprehensive training and strict operational protocols to protect the lives.
One of the factors suspected in the MV Golden Ray capsizing was improper weight distribution, which affected the ship balance. To avoid such risks in the future, it's important to use automated weight sensors and monitoring tools during the loading process. This system can track how weight is spread out across the ship, making sure it's evenly balanced both front to back, side to side. Real-time data help ensure that the center of gravity stays low and stable, which is crucial for a RoRo vessel, especially when it's carrying thousands of vehicles. By monitoring weight in real time, operators can spot any imbalance early and make correction before the ship even leaves port. This reduces the chance of a leak developing mid-voyage, which could lead a capsizing. Ultimately, combining tech-based loading supervision with human checks strengthens ship stability and increase the safety for crews, cargo, and marine environmental.
And as for the recommendation for risk mitigation to manage this risk and prevent the similar disasters, several recommendations stand out. First, implement multi-layered verification system which required independent checks of stability calculation to catch the errors before setting sail. Second, enhance crew training on stability software, emergency procedures, and watertight integrate to improve the readiness and response. Finally, adopt technological safeguard. So together, this measure can build robust defense against the human error. Thank you for your attention.
Looking forward, further recommendations include training crew to ensure watertight doors are always secured, regular audits to ensure compliance with the safety procedures, and ensuring the navigators are proficient in stability calculation. And it is also important to redesign the emergency escape rooms for the crew members' preparedness for external emergencies. So that's all from me. Thank you.
Thank you for watching. That's all from our group, Deepsea.